So somebody want to walk me through it? How do you do it? Which way is this thing going? Let's talk about all the little things that you know as of this moment. So where's this graph heading? Tails, x-intercepts, what do we got?
The tails are going opposite directions.
Okay, how do we know?
Because it's a odd power.
Okay, so something like this. Okay, that's good. Something else now. What else do we know? Anything about?
Y-intercept is -12.
Okay, y-intercept's -12. Okay, y-intercept's -12. I agree with that. That was good. Something else now. What else do we know?
X-intercepts?
X-intercepts. Do we have them? There's three of them. Okay, so there's three potential x-intercepts.
There's 2 turns.
Okay, good. 3 x-intercepts. There's 2 turning points. Okay. Good. You guys are starting to figure out all this stuff pretty quick by just looking at it.
There's not 3 x-intercepts.
There's potential.
Potential. Potential. Okay. What?
No symmetry.
No symmetry. Okay. How do we know the no symmetry idea? I agree with you. How do we know?
Just the x's are changing between even and odd.
Good. Yeah. One of the quick signs, it changed from even to odds to evens to odds. No symmetry. That's really good. So you guys see how you're getting super quick at this now. Like it didn't take you a few seconds, and now we know like the basic about just the polynomial. Like think about that a week or two ago. That was we were nearly impossible doing that at first. But now you guys are getting to the point where you just do it in a few seconds. Now what we got to get better at is doing the little things, like finding the x-intercepts if it has 3 or maybe it has less, or finding the figuring out where the turning points are, like the actual like peaks and valleys, the relative max and mins. How to find if it doesn't have x-intercepts, what were the other parts? Like was it imaginary or were they other things? So first, let's try to figure out these x-intercepts. Because I agree, there's probably 2 turning points. Let's see if it has 1 x-intercept or maybe it has 2. Let's see what we have here. How do we factor that thing apart if it's factorable? How do we try it? Like in the front, how do we do this?
X squared goes to x plus 6.
Okay, x plus 6, I agree with that. Keep going. What about that?
2 goes to x plus 6.
Okay, x plus 6. So, looks like we do have potential that this thing can factor. Notice that you got a -2 in the back. That way it turned out to be x plus 6 when it divided up with -2. And so what we have here is we have x squared minus 2, x plus 6. Okay. Agreed so far?
Mm-hmm.
Okay. What's the one x-intercept we know for sure? -6. Okay, so I agree with that. -6 down here. What if I told you there was 2 others? What if I told you there's 2 others? There is 3. That's one. Even though it doesn't look like it, there is 3.
Well, I guess a positive and negative, whatever the square root of 2 is.
Exactly. That's the actual answer. Because I know this doesn't look factorable, right? It doesn't look like it because 2 is not a perfect square. It is a difference of squares. It just doesn't have the square in it. So what you do is you go 2 parentheses plus minus x and x, and now I know that 2 is not a perfect square, but you're absolutely right. You just take the square root of whatever that number is, even though it's not a perfect number. Square root of 2, square root of 2, because when you multiply those together, you get the number 2, because you would get square root of 4, which is 2. So that's actually how you do that when it's not a perfect square number. You just take whatever the square root is. So those 2 numbers, so this is a negative root 2, and this is a positive root 2, and those are my x-intercepts. Now the reason why I can do that is because it's a difference, right? It has the subtraction sign in it. I think yesterday, or was it Friday last week, we did one where like you couldn't do it. Like it wasn't factorable because it had a plus. So, but this one does have it. So the square root of 2, I think it's like 1.4 or something like that. It's like 1.41, some weird decimal. So negative 1.41 and positive 1.41. And it looks like we're passing through each one. There's only 1 parenthesis of each. So this is kind of what we're looking at. Ooh, my goodness, I forgot about the y-intercept. Almost made a huge mistake. And there we go. Okay, that'll work. There. Make sense? Okay, not bad. Not bad for doing this. Now this is new. We haven't seen something like that before. That was pretty good. Now, if you're ever stuck in that situation, like right here, and you don't remember how to factor, you're like, oh god, I don't remember what words said about how to factor. That's what we talked about yesterday, you can do the quadratic formula. Because we had one, right? We had the x plus 6, we already knew that one. But the x squared minus 2, you can make that with a 0x in the middle, so it's a trinomial. And then you can do the quadratic formula. And again, the quadratic formula will be on the board on test day. It'll be on one of these side boards. So you'll have it on test day, which is sometime next week. But yeah, so that's kind of what we're going for. And you can do this problem and get the same answer that we just found in a few seconds. So there, it'll be a square root of 2. So the b is a 0, so this is negative 0, which is just 0. Square root, so it's 0 squared minus 4 times a times c all over 2 times 1. And eventually it turns out to be the square root of 2 still, because in the inside, this is 0 out front, so it's just plus or minus square root. Negative 4 times 1 times negative 2 is an 8. Divided by 2, 2 times 1 is 2. Square root of 8 is 2 root 2 if we simplify it. If you break it up, there's 2, 2, and 2. Kick out one of them. And if I divide by 2, the 2's go away, so it is square root of 2. So you can see, like, if you did the process, like the quadratic formula, you'd still get the same answer. Questions at all about the quadratic formula? Why I chose to do that? Because if you didn't know how to factor that thing, you could take and find the other two. All right. Do we feel comfortable with the process? Now, I want to get rid of this picture. I want to get rid of this, this formula here, and it's a little blurry, but here's the drawing. Cool. There's the drawing. So you guys are correct. That's exactly what it was kind of looking like. Had certain X-intercepts, and this is the part that really gets people. It's like, not sure if there's 2 of them. Okay? Not too bad. Now, what we could still do on this problem is we could still find the hills and valleys. We could still do that, right? Because those are using that differential quotient where you want to find a peak and a valley. I'm not going to have you do that today because I know that yesterday it literally took me 20 minutes to go through that tough problem at the very end of class. I don't want to do that today. I want to start with a kind of an easy one today and have you try one today, like a simple one. Okay? So I'm not going to pick one that's like an x cubed. It takes too long, so we'll just do like an x squared graph. So we can see like where the peak and valley is. Okay, questions at all about this stuff though? Okay, we'll come back to that whole find the peaks and valleys, the relative max and mins here in a second. Okay, next one. Ooh, that's small. Okay, I would like you to write this one down. I want you to try the same thing we just did. Last thing, we'll try this, and we'll try the peaks and valleys and whatnot. There's a rhyme and reason why I picked this one, and you'll see it here in a minute. anyone need more time than what I've provided you? All right, let's talk it through. Somebody want to volunteer? What do we have? Walk me through this problem. What do we got?
Take out an x squared.
Okay, so we're gonna pack the right one. X squared out of the front. What do you
And
get?
it's x minus 3.
Okay.
And then take out a 1.
Okay, good.
So it's 1 parentheses x minus 3.
Good. I like the way that you did that. A lot of people wouldn't get there. They would forget that you can take out a 1. They stopped and like, I don't know how to factor that. Take out a 1. 1 goes in everything. And it doesn't really change anything. That was good. Keep going.
And then parentheses x squared plus 1 parentheses x minus 3.
Okay. That was good. Good. So that's completely factored, right?
Yeah, then positive 3 for the x-intercept.
Yeah. So this thing has one x-intercept. Has x where it's a positive 3, right? The x minus 3 is a positive 3. Now this problem is different than the last one, and I kind of hinted at it earlier. I even said it. This one has a plus sign, right? X squared plus 1. That doesn't have roots. The reason why is that you can't plug in any type of number, square it, add it to 1, and get 0. Because you can't make negative numbers with an x squared. Like with the last one we did, it had a negative sign. So you could square a number, subtract 2, and get to 0. You could get there. But this one you can't. Like the smallest this thing will be is 1. Because if you plug a 0, square it's still 0 plus 1 is 1. That's like the smallest number this part will hit. It won't actually hit 0. Even if you plug in negative numbers, you square them, that turns positive, and you add 1 to it. So there's no way that there's like no roots for this thing. Now I want to talk about why. How do you know? Like how do we know for sure, other than just looking at it and seeing that you're squaring or adding a number to it? Let's do the quadratic formula like I just hinted at. All right, so this is x squared plus 0x plus 1. Okay, we're gonna do the quadratic formula again. So this is my A number, this is B, this is C, right? It's in descending order. And notice I plugged the 0 in, you have to put in all the missing terms. So if we do this, this would be x equals negative B plus or minus square root B squared minus 4 times A times C all over 2 times A. And what you're going to notice when we do this, okay, the 0's gone, that 0's gone, so it's plus or minus square root. Negative 4 times 1 times 1, that's a negative 4, and this is all over 2. What's the problem with that? Yeah, you can't take a square root of a negative number. You get imaginary numbers, right? Because what you're trying to think of, like what a square root actually means, is you're trying to find a number that multiplies on itself that would give you the number on the inside, what they call the radicand number. You can't take a number times itself and get negative. Because if they're both negative, the same number, if they're both negative, it turns positive. Like negative times negative would turn positive. If they're positive times positive, it turns positive. You can't mix and match. That's literally an imaginary number. In fact, how they train you how to do that in like algebra 2 or maybe even algebra 1 is you're supposed to take out the negative sign first and make it an I. That's the negative on the inside. It's actually the square root of negative 1. And then what's the square root of 4? 2. So this is actually 2i divided by 2. So it's an imaginary number. Now why it's imaginary is because of the graph. Okay, which way are the tails going? Yeah, down up, so it's like that. Kind of that's the normal direction. We're hitting positive 3. It's doing something like this. It's not actually hitting the x-axis twice. Like if this went higher, it would have hit twice, but it's hitting at positive 3. The x-intercept is negative 3. That's what kind of told me which way to draw that thing. That's why it has imaginaries. It had potential to hit the x-axis 2 more times because of that little bubble, but it didn't. And that's the idea. Okay, does that make sense? Like I wanted to bring this up yesterday. Like we didn't really discuss it. Like what happens when you don't have more than one x-intercept. It's that situation and how you know like how we potentially find it. It's because of the quadratic. That's why we kind of brought it up yesterday. Okay, do we feel a little bit better about some of the problems I kind of hinted at yesterday? Okay, now since we found these, you could still do like let's say you didn't know how to factor this thing apart. You can still do the rational root theorem where you take the back number and the front number, you break it up, You try to make every combination of plus and minus numbers, and you check by, synthetically plugging them in. Eventually you find that 3 is the answer. Like this one's a really easy problem. We're gonna do that rational root theorem to guess where this thing is going. Like the types of roots you have, because that's what the rational root theorem is all about. You take the back number, you put it over the front number, you make every factor of this number, which is 1 and 3s, every factor of the bottom, that's 1, so there's only a couple options. So it's kind of easy. So in fact, the positive 3 is the number that worked. So you can do that, you can plug it in, you can divide it out, and eventually you get down to the reduced form, which would be this thing. You can't factor it apart. So you can do it the old school way. This stuff that we spent 15 minutes doing yesterday. Okay, questions, comments, concerns about that problem? All right. So here's a problem I'd like you to write down. Okay, by the way, let me show you the picture. You guys already guessed, there's the picture. That's what I just kind of showed you a little bit ago. Okay, hit 3, hit -3, kind of do a little like bubble where it's not actually hitting the x-axis 2 more times, it hit once. So, but the simple fact that you guys can factor a little bit better allows us to get to that answer really quick without having to do the rational root theorem. Okay, this is one of my last problems today. No joke, last problem today. I just want to make sure that we got a chance to figure out, the max and min. I'm going to do an easier problem. And what happens when you can't factor this thing apart? Like when you have to do rational roots, seeing where this thing goes, that type of thing. All right. So 2x squared plus 8x plus 3. Okay, I'd like to write this down. Why pick this problem? Number 1, can't factor it. So we can try the rational root theorem, but there's a reason why I picked this one. It's because the rational root theorem might fail you. So there's one of those things we just have to see it. Where are the tails going on this problem?
Both up.
Both up. It's a square. It's got 1 turning point, so it's going to look like a U shape. It's a parabola. It's a quadratic. So we can do the quadratic formula and you can figure out, the X-Intercepts, but I want to just kind of walk through the process here. If you're going to try to factor this thing apart, it's going to be plus plus, you'd have to break up the 2x and 1, 2x and 1x, you'd have to break up 3. There's no way, no matter how I switch these numbers around, that you're going to get 8 in the middle. The most you can get is probably 7. That's probably the most you're getting in the center. Okay? So that's why it's not factorable. So if you wrote that down, erase that. That's not a factor of it. So doing the rational root theorem, you take the back number, you put it over the front number, you make every, break that up into all the factors, that's 1 and 3s, break up all the factors of 2, that's 1 and 2, we didn't do any of these yesterday. Then you make every combination of these numbers without repeating. So like for instance, 1 over 1, 1 over 2, it's half, that's one of our options now. 3 over 1, and 3 over 2, 3/2, which is 1 1/2. So these are every combination of numbers that we can have that could be potentially X-intercepts. So there's 8 numbers we'd have to check. And again, you plug one of these, and you can use decimals, like for half, you just plug in 0.5, you plug it into this problem, and you see would it give you actually 0, or you try -half, and you just keep going and keep plugging. Okay, questions at all about the process for how to do the rational root theorem? Okay, you find potentials, you plug them in one at a time. Okay, I think the number, I think it's, I don't want to be but anyway, checking these out, we can do the quadratic formula to see where the X-intercepts are. Because if, let's say this fails, like you can't find any here, you can still fall back to this formula on this problem. Usually on the bigger problems, this rational root theorem always works. But doing the quadratic formula, -b plus or minus square root b squared minus 4 times a times c all over 2 times a. So this is -8 plus or minus 64 minus, now this is 4 times 2, which is 8 times 3, which is 24, all over 4. And here's how you know if you were able to factor it or not, or if you made a mistake and you didn't know how to factor it in the first place. You actually subtract these numbers, bless you. You subtract, you get what, 40? Like perfectly the square root of 40. Is that a perfect square number? No, it's not. So it wasn't factorable. That's what it tells me. In fact, since that's a positive number, this thing actually does have roots. It will actually hit the x-axis twice. It's not imaginary. It does happen. The square root of 40 is just above the number 6. It's like 6.2 or something like that. It's just above 36, so it's just above 6. So you're going -8 plus, 6-ish. So it's -2 divided by that. So it's about half-ish, it's around there. -8 subtracting 6-ish. That's -14 divided by 4. Was that about 3? Somewhere in that range. -3, I mean. So you're in that ballpark if you type in decimals. So the numbers are going kind of in this range where it's going about -half-ish and about -3-ish. This is kind of where it's going. And the tail side go up. Does that make sense? Now, where's the y-intercept at? 3. So it's gonna hit 3 up here. So you get a sense for how this works. And again, how I got those x-intercepts, I'm just guessing what those numbers are. I'm not even using a calculator. Now, questions at all about the setup for the rational root theorem? Where are my numbers somewhat correct? Are they close? Where are you typing them?
Huh?
Where are you
I
typing?
didn't get it.
Oh, okay. I didn't know if you typed them or not. All right, but now, the whole point of this is fine. Rational roots, figure out numbers, you try to see if any work. If they don't, then you go to quadratic formula. If you don't have the luxury of doing quadratic, usually the rational roots figured it out for you. There's usually one that worked. But I want to find that value. How do we find the values on these problems?
You plug everything into x plus h.
Yeah, we do that crazy formula of this thing. F of x plus h minus f of x over h. And eventually at the very end, you approximate when your h turns into 0. You're like approximating when slope would eventually be 0. It's not actually when slope becomes 0, that's what we're actually doing, but it's when the h's get so close together that it gets to that peak and valley. So you're kind of figuring out when you pick two different x's that are so close together and nearly approximate like the point that I'm looking for. I'm looking for this dip. Like where's that spot? It's an actual number. That's what I'm looking for. Okay, does that make sense? Now we didn't do one of these easy ones yesterday. I did like this overly difficult one yesterday to show you kind of the level that you should be at. I kind of know what this problem's going to be before I start, but let's go through this problem. And let's walk through the process that you'd have to do on the test. There'll be at least one of these on the test you're gonna have to do by yourself. And again, I would pick something very similar to this style. Like easier, it will take you a few minutes of work because this is something that you did in the previous chapter test. You had to do differential equations on something almost exactly like that. So you should be able to do it still, but you have to do that one extra step. You have to go one more step and figure out why do we actually do it now. So plug in x plus h in. So taking that problem and plugging in the x plus h into all the x's. You agree that's plugging the x plus h into the original problem? The 2x squared, 8x, 3, x plus h is good in everything. Then we're going to subtract the original function, which is the x squared plus 8x plus 3. Oh, sorry, 2x squared plus 8x plus 3. And this is all over h. And eventually we will approximate when the limit as h approaches 0. Eventually I want h's all to turn out to go away so I can figure out what that number is. Okay, how do I do that first parenthesis? How do I do this thing? What is this? How do I do this math? FOIL. Yeah, you FOIL. You don't distribute the power 2, you actually FOIL. There's actually two parentheses. I'm gonna do this in my head just real quick. If you actually wrote two parentheses, like FOIL. So I actually did FOIL first, second, last. I get x squared, so that'd be 2x squared. XH, there's 2xh's, take it times 2, so it's 4xh's. And then h squared, you take it times 2, that's 2x, or 2h squared. Sorry, I'm foiling it and distributing the 2 at once, sorry. The next one, distribute the 8. 8x plus 8h plus 3. Okay, so that's all of this stuff so far. Again, I foiled, distributed, sorry, trying to do it all at once, just make it short. In the back, what do I have to do?
Do it all.
Yeah, distribute the negative to all that stuff. Negative, everything. This is all over h. Okay, now what should happen if you did this right? What do I get to saying?
H's go away.
Yeah.
Anything without.
Anything without an h should go away. So the 2x squared is gone. Boom, that's correct. 8x is gone. 3's are gone. Anything that does not have an h should go away at the first step. Now eventually we will cancel out all the h's later because we'll turn them into zeros, but you can't do it right now because you can't divide by 0, so you can't just plug in 0 right away because there's a 0 on the bottom. So you have to get rid of that. We have to divide those h's off. So let's keep going. What do we get down to is we get down to 4xh plus 2h squared plus 8h, and I'm gonna divide everything by h's. And now that I'm here, because that's getting rid of all the things that don't have h's on them, basically. Now I'm gonna divide everything by h and then plug in zeros if there's any h's left over. Because I can't plug in the right, I can't divide by zeros. So let's divide everything by h. I have 4x plus 2h plus 8. That's dividing everything by h. Because you can divide each item, so they're 1 h less. And then now what I'm going to do here is plug in 0 to all the h's that are left over if you're back to that point, because it won't cause any problems. I'm not going to divide by zeros anymore. So what I'm left with this. I'm left with 4x plus 8. Make sense? Like what I'm stuck with. That part right there, that item, whatever it is, it could be a polynomial, mine's a nice simple binomial. That thing will give you whatever x's are the peak and valley. That thing right there. So what you do is you solve it. You set it equal to 0, you do quadratic formula, you do the rational root theorem, you do whatever you need to. If I set that thing equal to 0, can I solve that thing? Is it easy enough that I can just solve it? Yeah. Subtract this over. Divide by 4. This spot right there is where the peak and valley is going to be. It's going to be at -2. I didn't need to factor it apart. I didn't need to do quadratic formula to it. I didn't need to do, the rational root theorem. That thing was so simple. I could just solve for x. That x number, -2, is where that peak and valley is going to be. That's the x coordinate. All I need to do is figure out the y coordinate. If I want to figure out the y coordinate, like where that valley is, you just plug in -2 into this thing. Because that was the number where it's going to give me my peak and valley. This is going to be 4 times 2. This is -16 plus 3. This is 8 plus -16 plus 3. So that's -8 plus 3. What is that, -5? I did everything right in my head. Is that correct? -8 plus 3 is -5. So that's the coordinate where the peak and valley is going to be. That's the lowest point on my graph. In fact, it is the absolute minimum spot on the graph. There's no lower point than that. So it wasn't just a relative, it was actually the lowest point. That's a problem you should expect to do on a test. And yes, I will ask for you to actually figure out the coordinate. So once you find an x number, actually go back and plug it in, figure out where that coordinate is. That's how I found out the -5. Just take whatever that spot is, the -2, just plug it in. But I'm going to pick an easy problem, like that. That's what you should be expecting on the test next week. Questions, comments, concerns about any of that? I'm not going to pick some crazy, stupid, difficult problem. I'm going to pick something like that. It's easy enough. You can do it in a couple minutes. That took me not even 5 minutes to do that. And I was trying to explain it at the same time. All right. What we're going to look at tomorrow, because we're done for the day. What we're going to look at tomorrow, we're going to look at doing the rational root theorem one more time, where we have to do it for a bigger problem, and find potential x-intercepts. We'll do one where I'll have you try it out. If we need to, we'll review this stuff one more time just to make sure you know how to do it for kind of an easy problem, if you need it. But the more or less what we're doing tomorrow is we're gonna be focusing on, it's called Descartes' rule of sign. It's this thing that I remember learning in Algebra 2. I'm just gonna refresh your memory what it is. It's to help us with potential X-Intercepts on a really big problem. That's why we're gonna do it for the one problem we're gonna do tomorrow. And we're gonna look at long division. We've done synthetic. We did it with the rational root theorem, but we're gonna do it with long division tomorrow. And that's gonna be the first sign of that. That's one of our last sections. Like that's it. So possibly by the early part of like the end of this week, like Friday, we'll potentially start reviewing for that test next week. That's about as early as I want to put it. Make sense? We'll kind of play it by ear though. If I need to push back next week, that's fine. But I want to make sure that you know we have like a test coming up soon. Okay, that's it for today. So you have about 6-7 minutes here. If you're not here yesterday, or if you just didn't pay attention to it, you did have homework due yesterday. That was your page 912. That was all the graphs, all the simple stuff. I didn't have you do all those crazy complicated things. But that's it for today. You have a few minutes here, you can kind of relax.
Taking that, is that